Imagine gripping a wooden handle as the stone blade twists loose and drops into the dirt. The edge is sharp, but the tool has failed at a strip of black glue. At Campitello in Italy, archaeologists found 2 flint flakes partly covered in birch tar, at least 191,000 years old. That was long before pottery could serve as a still. Experiments show several ways to make the tar without a pot. The trouble is that no one can yet prove which method Neanderthals used. A loose stone flake can already cut skin, hide, wood, or meat. Fitting it to a handle makes it easier to control and lets the user apply force without wrapping a hand around a sharp edge. The improvement comes with a new weakness. Stone, wood, and glue now have to behave like one object. If the black seam between them gives way, the whole tool stops working. That seam rarely survives. Wood rots, plant fiber and sinew disappear. Most natural adhesives break down until nothing recognizable is left. Archaeologists usually recover the stone and have to infer the missing parts from wear, fractures, or residue. Campitello was different. 2 ordinary-looking flint flakes still carried patches of black material that chemical analysis identified as birch tar. The finds came from sediments with a minimum age of about 191,000 years. No wooden handle survived beside them, and no one watched the tools being assembled. The residue is the direct evidence. It shows that European Neanderthals were manufacturing birch tar and applying it to stone. The shape of the finished tools and the exact steps used to make the adhesive are reconstructions. Birch tar does not drip naturally from a cut tree like sap. It starts with the white, papery outer bark. Heat breaks that bark down and releases oily compounds. If those compounds are collected instead of being burned away, they cool into a dark mass that can be softened again near a flame. Warm tar can be pressed around a stone insert. As it cools, it becomes firmer and holds the pieces together. For a long time, the production problem seemed almost impossible without pottery. Researchers knew that later people could heat bark inside ceramic vessels and collect the tar in another pot. Neanderthals had no ceramic still. That led to underground reconstructions made from pits, bark containers, branches, stones, mud, and carefully managed fire. Then experimenters tried burning birch bark beside a sloping stone. Smoke and hot vapor struck the cooler stone surface. A thin black film accumulated there, much like grease collecting above a smoky stove. The experimenter scraped the film off with a flint flake, added more bark, and repeated the process until the scrapings formed a small lump. No sealed chamber was needed. The reaction happened in open air, where every step was visible. In one experiment, researchers collected bark and produced about 0.6 grams of tar in a single 3-hour session. That amount sounds trivial until it is placed in a tool joint. They warmed the tar, fixed a flint flake inside a slotted wooden handle, and tested the tool. A mechanical arm dragged it through 170 scraping strokes on wood. The same tool was then used for about 20 minutes of cutting, scraping, and removing tissue from a calf bone. The connection showed no visible weakening. Open-air condensation is only one option. A roll of bark can also be buried under hot ash and embers. After roughly half an hour, the roll can be opened and tar scraped from between its layers. Another method places rolled bark in a shallow pit with a small bark cut below it. Hot embers heat the upper bark while tar runs toward the cooler collector. A larger raised structure separates the bark and the collector with twigs, stones, or both. Mud closes the structure, and a fire burns around the outside for several hours. The bark heats in a restricted atmosphere, while tar drips into a bark or stone receptacle beneath it. These methods use no ceramic pot, but they do not all work without containers. A folded piece of bark can serve as a cup. A hollow stone can catch liquid. Earth can support and seal the heating chamber. The title's missing pot is a real constraint. It does not leave Neanderthals standing beside a fire with nothing but bare hands. Time, attention, fuel, bark, and yield vary from method to method. So does the material produced. In one set of laboratory tests, tar made by open-air condensation reached an average maximum shear stress of about 1.14 megapascals. A raised structure left to cool overnight produced tar with a value of about 0.95 megapascals. A similar structure opened after 5 hours produced a softer and substantially weaker sample. Those figures belong to small experimental batches joined and tested under defined conditions. They let researchers compare one batch of tar with another. They cannot support the claim that Neanderthal glue was stronger than stone. Stone and adhesive fail in different ways, and a comparison means nothing unless the materials, joint, direction of force, and test conditions are specified. The experiments prove that several no-pot methods can produce usable tar. They do not tell us which method produced the ancient residue. 2 pieces from Königsaue in Germany appeared to offer an answer. A 2023 study compared their chemical signatures with modern tar made through different Stone Age methods. The researchers found similarities with tar produced underground in restricted oxygen. They argued that the Königsaue makers had used a controlled process hidden beneath the surface. That conclusion mattered because an underground structure cannot be watched once it has been sealed. The maker has to prepare the parts, control the fire, and trust that the unseen process is working. If the interpretation was correct, Königsaue preserved evidence for a demanding learned technique. The chemical distinction did not hold up cleanly. Another 2023 study made tar with several methods and found too much variation to identify an ancient production route reliably. In 2025, researchers tested the Königsaue argument more directly. The infrared signals linked to suberin, the part of birch bark used to support the underground interpretation, also appeared in tar made by open-air condensation. Even nearly identical experiments produced different spectra. Königsaue may still have been made underground. The surviving chemistry cannot yet prove it. A 65,000-year-old hearth in Vanguard Cave, Gibraltar, provides a different kind of clue. Its shape and burned contents are compatible with a controlled heating structure. Researchers built a replica and used it to process rockrose leaves into a tar-like adhesive. The experiment worked. The archaeological hearth, however, contained no preserved sign saying what it was built to make. The raw material was rockrose rather than birch, so it cannot supply the missing Campitello recipe. Adhesive technology was also developing elsewhere. Around 70,000 years ago at Sibudu Cave in South Africa, Homo sapiens used plant gum mixed with red ochre on hafted stone tools. Reproduction experiments show that ingredients, proportions, heat, and moisture can change how such mixtures behave. This is useful comparison, but it belongs to another population, region, and adhesive tradition. It cannot be used as evidence that Neanderthals followed the same recipe. The debate over intelligence became attached to the glue because some reconstructions looked difficult. If birch tar demanded an underground installation, the thinking went, its makers must have planned several steps and learned a procedure they could not observe. Open-air condensation showed that usable tar could come from a much simpler arrangement. That result does not make Neanderthals simple. It means the existence of tar alone cannot tell us how many steps they followed or how the technique was taught. The residue shows material transformation and successful hafting. Claims about cumulative culture depend on identifying a production method, and that is precisely where the evidence remains unsettled. So how did Neanderthals make glue before pottery? They heated or burned birch bark and collected the tar released from it. They could have scraped it from a smoke-darkened stone, recovered it from bark buried in ash, or caught it in a container built from bark, stone, and earth. Each route works with materials available in the Middle Paleolithic. The smallest answer is secure. No ceramic pot was necessary. The larger answer remains open because the finished tar has survived more often than the place where it was made. We have the black seam. We still do not have the complete recipe. With birch bark, fire, stone, and soil in front of you, which method would you try first? Scraping tar from an open stone or building a sealed pit?